Hi and welcome to another Kirby Maths video. This time we are going to be finding the midpoint of a line given the coordinates of the end of the line, so the middle of a line if it is drawn on a set of axes. I've got two coordinates here, coordinate for A which is 6, 3, so 6 along, 3 up, and then the coordinate for B which is 8 along, 1 up. Now we could find this by drawing and measuring, but the problem with that is, first of all, you've got to have some squared paper and a ruler, and secondly, if it's not a whole number, then it's difficult to measure and difficult to draw and find the exact midpoint. So using this method, we can just find it without having to do any drawing. So the first thing we need to do is remember that this is the x part of the coordinate, the along bit, and this is the y part, the up and down bit, and the same over here, we've got x and we've got the y bit, the along bit and the up and down bit. Now because we want to be able to differentiate them slightly, we're going to put a little 1 and a 2. So this is my first coordinate, so I'm going to put a little 1 down here and a little 1 here. This is x1, y1. I don't put it above the letter because then otherwise it would look like a power and it might be squared or something like that. So here, this is the second one, so x2, y2. Now we have a really complicated looking formula, but actually when I break it down you'll see that it's actually not that difficult at all. So if we're going to find the midpoint, we need to add the two x coordinates together, so x1 plus x2, and then halve it. That would give us our x part of the midpoint. And then there's a comma, and then we add the y bits together, so y1 plus y2, halve it, and that would give us the y part of the coordinate. So to begin with, it looks really confusing, but when we put some numbers in, I can show you that it's actually not that tricky. Putting the numbers in from here then, we've got x1 is 6 and x2 is 8. So we would write 6 plus 8 all divided by 2 and a comma, and then the y bits 3 plus 1 all divided by 2. And as always, we need to show this part of the working because this is where we'll get our first mark in a question for the substitution of the numbers that we've been given. 6 plus 8 is 14. Half of 14 is 7. 3 plus 1 is 4. Half of 4 is 2. So the coordinates of the midpoint would be 7 along, 2 up. Now if I do a little sketch over here, and you don't need to do this, but I'm just showing you how it all works. If we think where the point A might be, so 6 along, 3 up, very roughly, that would be point A. Point B, 8 along, 1 up, here. And then using this calculation, I have said that the midpoint, M, is going to be at the point 7, 2. So 7 along, 2 up. And if I was to plot it accurately, you would be able to see that the midpoint M is in the correct place. But like I said, you don't need to do the diagram. I'm just showing you where we've got our answer from. So let me do another example, and some of you might find it useful to colour in your x part and your y part of the coordinates to give you an idea of how you can keep track of your numbers. So if we have these two coordinates, and we're finding the midpoint of 7, 2 and 9, 6, I'm going to colour my x parts orange. That's these two bits with a highlighter, and then my y parts of the coordinate green with a highlighter. And then I'm going to use this formula where I add the x bits and halve it, add the y bits and halve it. So the x bits are these two, so 7 plus 9 divided by 2, and then my comma because it's a coordinate, and then 2 plus 6, again divided by 2, will give me the midpoint. If you want to do at this point, you can keep the numbers, the colours consistent, so you can see where your numbers are coming from and where they're going. So 7 plus 9 is 16. Half of 16 is 8, with a comma. 2 plus 6 is 8. Half of 8 is 4. So my midpoint would be 8, 4. 8 along, 4 up. And my 8 was the orange bit, which was the X bit, and my Y was the green bit, which is the up or down bit. Okay. And finally, I just want to show you a really quick example where it doesn't always have to be a whole number. So in both of my examples here, 7 along, 2 up, and 8 along, 4 up, it doesn't have to be a whole number, and it also doesn't have to be a positive number, because of course, if you remember, your coordinates can also go in the minuses here and in the minuses here. So if you've got minuses, then you just have to be a bit careful about your adding. Okay. Let's do a couple of examples then to just show that. So first of all, if I have the points 3, 2, and 2, 7. Okay, so I add the X bits together, 3 plus 2, and then halve it. And then the Y bits, 2 plus 7, and then halve it. 3 plus 2 is 5. Half of 5 is 2.5. So that's the X bit. And then 2 plus 7 is 9. Half of 9 is 4.5. So that would be the Y bit. So that would be the coordinates of the midpoint between these two coordinates. And you can see that they're not whole numbers. So you would go along 2.5, up 4.5. But obviously you would still be able to plot that on your axes. If we had some negative numbers, if we had the points -3, -7, and 1, 5, and we were trying to find the midpoint of those two coordinates, exactly the same. We just put our numbers in, and then we're really careful with our adding and then halving. So we have got -3 plus 1, and then divide it by 2, and -7 plus 5, and then divide that by 2. So -3 add 1 is -2. Half of -2 is -1. -5. Oh, I've got the 5 in the wrong place. Hang on, that's not -5, that's -7. Sorry, I was talking and trying to write at the same time. This -7 here. -7 add 5 is -2. And -2, half of -2 is -1. So in that case, both of the coordinates came out to be negative. Okay, so it starts off with a pretty scary looking formula with kind of x1, y1 and all the rest of it, but you just have to remember that you add the x bits together and halve it, and add the y bits together and halve it. Being careful, if you have negative numbers, then you just have to take a bit of extra time with your adding. Thanks for watching.